Good evening, everyone. This is a special video for a major coastal storm that is going to be on the way for this upcoming weekend. Looks like from about tomorrow evening on through much of Saturday, we're going to be dealing with a significant coastal storm. So because this is kind of the first coastal storm of the season, if you want to call it the cold season, not really, it's the summer. It's a very unique storm and it has a lot of moving parts, so I wanted to kind of share not only what I provide premium members, but also for the public, and kind of get the word out on why this storm is potentially a big deal on a variety of different levels. So I'm going to show you some of the data. We're going to look at the observations and then the model data so that we can get a pretty good idea of what we can expect. So let's go check this stuff out. I'm going to close this out, and here we are. Okay, so we start out with the observations. In order to do a real forecast, a good forecast, you have to look at the observations first. Because if you don't know where you are, then how do you know where you're going, right? And so where are we right now? We are dealing with a rather tropical air mass, but you haven't seen anything yet. Currently, we have temperatures ranging from the lower to mid-70s over portions of Connecticut, Long Island, New York City's upper 70s, Philadelphia Metro upper 70s to lower 80s. Granted, we're not talking about hot weather conditions here. We're actually slightly below normal. But take a look at the dew points. Upper 60s to lower 70s. This is a very moisture-loaded atmosphere already. We already have a few scattered showers over the region, as we are getting some warm air transport as our high pressure system is exiting, and our winds are very lightly coming from the south, slowly veering to the southwest. At the surface, what are we seeing? Well, we have our warm front here. Very important warm front to consider. Why? I'm going to show you in a moment. But currently, this cold front is going to be the main player here. Because where this cold front stalls out is going to tell us where our low pressure system for Friday, for tomorrow evening on through Saturday is going to set up. This is the boundary that is going to basically ignite this storm. And so where this cold front sets up is going to have a major impact on who gets the heaviest rainfall. So remember that as we move forward. In terms of this warm front, I'm going to show you this data right here. What this is precipitable water. So you might be asking, what is precipitable water? Well, what precipitable water values are is basically a measurement of the amount of water in the atmosphere. So my general rule is that between 1 and 1.5 you can get some heavier downpours. But when you go above 1.5 inches, that's some tropical downpours. And then when you get above 2, that's when you can get your real significant flash flooding, where you can get your scenarios where you can get half an inch to an inch of rain per hour. Very, very impressive stuff. And so remember our warm front boundary. I was basically in the Ohio River Valley, and look what's behind that warm front boundary. This is some very tropical air. And this is some very deep moisture. And this area of moisture is going to be heading right towards the mid-Atlantic, specifically over, let's say, southern Long Island, central and southern New Jersey, and southeastern Pennsylvania. So remember that point as we move forward. So the current radar that we have right now, we have a few scattered showers. And in that tropical air mass, you have some thunderstorms producing some very heavy downpours and flash flooding. Currently, we do have a flash flood watch for central New Jersey, southern New Jersey, and southeastern Pennsylvania. I would not be surprised that it is extended further north towards Long Island and New York City as well. So definitely be on the lookout for that. But currently, as we stand right now, basically from central New Jersey on south, we have our flash flood watches. Now let's talk about the setup here. Here we have our water vapor satellite picture. Now I love using the water vapor satellite picture because it allows you to really see all the mechanisms that are setting up in the atmosphere. So we're going to draw some important features here for the setup of our storm. So let me pull this up. Okay, and perfect, freehand. Now the first feature that I want to show up, and let me get the right color here. Then you might be thinking, oh, it's going to be this feature here. No, it is going to be this right here. This area and this area. Now you might be asking yourself, Stephen, who cares? This is to the east of us. Why does this matter? Well, this blocking mechanism and this blocking mechanism is going to act like a wall. And so let me draw that wall. I'll draw it in orange. And so this wall is going to set up, because of this blocking mechanism, it's going to basically line up right about here. Okay? In fact, let's make that thicker, just to kind of make our point, right? So here's our wall. Now you might be wondering, why is this such a big deal? This blocking setup is what allows our storm, which is actually this disturbance right here. I'll circle it for you. This is our storm right here. This little shortwave is going to run headlong into this block. And so what it's going to do, it's going to dive towards our cold front, instigate an area of low pressure right here, and that low pressure system is going to take a beeline right towards the Delmarva Peninsula. And it's going to run into this wall. Now this wall is going to force this low pressure system and upper level shortwave to intensify, to cut off, and what that's going to lead to is that it's going to lift all this tropical moisture that is sitting over the northern Mid-Atlantic and lead to some very intense rainfall. So that's pretty much the whole setup for this storm. The block sets up. Here's our high latitude blocking, all very nice, all set up. Here comes our shortwave diving into our trough with the cold front stalling out. Our wave of low pressure develops along that frontal boundary and then heads right towards the Mid-Atlantic coast. It has nowhere to go, so it sits there and spins for Friday night, Saturday, into early Sunday morning. Now, originally the forecast was for this storm to kick out of here by Saturday morning, but because this block is so impressive, and I've been talking to premium members to watch out for this block. I've been kind of honing in on it, saying, hey, this might be an issue here. But to be honest, what I've been seeing this afternoon via this setup here, and let me show you the animation once again on this. Take a look at the animation it's setting up here. This is just spinning out here. This whole trough is starting to become enhanced. We have this block out here, and then you have your short wave diving into this trough, all interacting together. And it sets up an environment that is almost textbook, if this was winter, for a powerful nor'easter with very heavy precipitation. So pretty much everything that we need is pretty much lining up, and when we zoom in, you can see the block starting to set up. Notice that this jet stream is starting to push a little bit further west. This area of moisture is slowing down its progression. Here's our cold front boundary, slowly heading towards the coast. Here comes our short wave diving south towards the cold front, and it's going to basically stall out and instigate these low pressure systems, and voila, we get our storm. Now this is the infrared satellite picture. This is going to be important to watch over the next 48 hours. Because then what's important here is what we're going to be watching out for is for these colder cloud tops to start to develop. When you start to see an explosion of colder cloud tops on the northwest side of a low pressure system, that means we're seeing rapid intensification of a low pressure system. And look for that to start to set up over New Jersey, southeastern Pennsylvania, and really the southern Mid-Atlantic as we head into tomorrow evening. So I'll be showing this again for future discussions as we move forward. So let's look at some of the model guidance here to kind of walk you through and explain to you what's happening here in the model guidance. We're going to use the European model guidance in this case, and it's from Storm Vista Weather Models. And what I'm going to be showing you are the various levels of the atmosphere and why it's important, okay? So first we start off with at 250 millibars. And what I want to show you are two important factors here moving forward. First of all, as we head towards Friday afternoon, see this jet streak here? This jet streak is very important because what it does is that it allows the amplification of the trough over the eastern United States, specifically over the Tennessee River Valley. That starts to set up the intensification of the trough at 500 millibars. Meanwhile, look at this jet streak that starts to develop here over portions of New England. What we're going to see as we move forward in this setup is this trough becoming stronger and stronger. Now you see this jet streak here by Saturday morning. Why is this important? What's happening here over the mid-Atlantic is what we call divergence, okay? You're having air rapidly leave at the upper levels of the atmosphere. Now there has to be what we call conservation of mass. So if you have mass rapidly leaving a location, it has to be filled somewhere in order to create a balance. And so what that balance is that you have air rapidly rising in the atmosphere. That's what we call lifting. So we have intense lifting that is developing over the northern Atlantic that supports the potential for an intensification of the 500 millibar trough and also heavy precipitation. So that's step one. Step two is what we're seeing at 500 millibars. Now what's interesting here as we move forward is here comes our trough diving in, and it's a positively tilted trough. Okay, so you would think that, hey, it should move pretty quickly. But in reality, what happens here is that as this trough intensifies, it starts to cut off. Why? Because of the block over the western Atlantic. So as this intensification takes place, heights begin to rapidly fall over the northern Mid-Atlantic, especially over portions of New Jersey and southeastern Pennsylvania, and that extends down towards the southern Mid-Atlantic as well. And what that rapidly falling heights does is that it allows the atmosphere to start to rapidly cool. So again, this is another indication of air rapidly rising, colder air aloft interacting with the tropical moisture at the surface, and you see as a result, you can see that set up with the upper level lows up. Now, what's really important here that kind of stands out to me is that this 500 millibar low is basically not really moving all that much on Saturday afternoon, Saturday evening, or early Saturday night. And what you're seeing here is the upper level low kind of lingering right over the northern Mid-Atlantic, keeping the atmosphere to stabilize. That's going to be important as we move forward. So remember that. There's a stabilization in the atmosphere. Taking a look at the PVA, which is positive vorticity advection. Again, we're seeing a setup here where strong lifting is being focused right over the northern and southern Mid-Atlantic, supporting the heavy rainfall. Notice how the 500 millibar low is kind of elongated, kind of being pulled by this northern trough here, but then gets completely cut off, and then the trough just kind of lingers over the Mid-Atlantic coast. At 850 millibars, we have colder air. Again, this is summer, so it's relative. Setting up once again as this storm develops. Now, notice the 850 millibar low, okay? By the time we get to Saturday, it's basically to south of Cape May and around the Delmarva Peninsula. And you can see how we have colder air kind of wrapping in. Again, this is summer, so it's relative. But what this leads to is a very strong thermal gradient over the northern Mid-Atlantic, over central New Jersey, southeastern Pennsylvania, southern New Jersey. And so you're getting this intense, what we call frontogenesis. So again, intense lifting over this location. Typically in these type of storms, you get your heaviest rainfall, or in this case, precipitation or heavy rainfall, to the north and northwest of the developing 850 millibar low. And so when you move that forward with the winds at 850 millibars, what we look for in terms of the jet streak at 8 to 15 millibars is that the alignment of this jet streak of moisture coming off the Atlantic Ocean at the mid-levels. So let's start putting this all together. We have strong lifting at the upper levels. We have a strong thermal gradient at the mid-levels. Strong moisture transport at all levels of the atmosphere. All of this combines into heavy precipitation. Throw in the fact that we have cold air aloft, and what do you end up with? You have convection or thunderstorms embedded in this heavy rainfall. So, when we take a look at the precipitation shield here, you start getting these forecasts popping up. Now, notice these bullseyes here. What this is a warning. It's a warning about convective feedback in the model guidance, okay? Are we really going to see 5-6 inches of rain? Not widespread, I don't think. Okay, what we're setting up here is a situation where we get this low pressure system developing off the Delmarva Peninsula, rapidly intensifying, wrapping moisture in, wrapping heavy rainfall over central and southern New Jersey and Philadelphia and pushing into New York City. And what you're going to see is basically banding. And with this banding, you're going to get this convective precipitation setting up. Now, where these thunderstorms set up within this rain shield, we're going to see the potential for rainfall amounts to go over 2-3 inches of rain, but it won't be widespread. So what I'm thinking here is that in this setup, from about Long Island to New York City through the northern suburbs of Philadelphia on south, we're looking at 1 to 3 inches of rain. You're going to have pockets where that rainfall is going to go over 3 inches, and you're going to have some significant flash flooding. Because of all the strong lifting involved with this storm, you're going to have a tremendous cutoff to the north of that heavy rain. So the idea that, let's say, portions of Connecticut, the Hudson River Valley, northeastern Pennsylvania barely sees any rainfall out of this is a possibility here, okay? Now, I wouldn't go as far as saying that they will get nothing, but I could certainly see where they can just get these scattered showers and you get maybe a quarter to maybe a half an inch of rain out of this whole scenario. While just to your south, you're talking about an inch of rain, 2 inches, and possibly even over 3 inches in a very tight gradient with the development of this storm. The other factor that I'm really concerned about, and I'm going to show you at the surface map here, as we set up for this storm, notice where the low pressure system is. Now you're going to have strong east-northeasterly winds lingering along the coast from about basically Friday night on through Saturday, and then starting to taper off towards Sunday. This is going to lead to the potential for coastal flooding along the New Jersey coast, in a battery in New York City, portions of the Long Island Sound. So I'm rather concerned about that. I don't see any advisories out there for that yet from the National Weather Service, but don't be surprised if that sets up as well. So what I'm looking for in this storm is the rain becoming widespread tomorrow night, becoming heavy tomorrow night into Saturday morning, lingering on through Saturday, and then slowly exiting Saturday night into Sunday morning. With that being the case, it looks like this weekend is going to be, well, pretty ugly. So that is the forecast. That is the latest update on this developing storm. I'll have more on this storm tomorrow with regular updates, premium videos, regular videos, and we'll nail down this storm and see how this all plays out. Thank you for your time. I hope you enjoyed the video, and as always, stay safe out there.